Hi all, I am K. Surya, working as Assistant Professor in the Department of ECE at SNS College of Technology. In this video, let us see about Z transform, which is a tool used for analyzing the discrete time signals and systems. So let us see an overview of Z transform, which is a powerful mathematical tool used in signal processing, control systems, and other engineering disciplines. So this presentation covers the definition of is a transform, what is region of convergence, properties of region of convergence, and applications of is a transform. So let us see what is a transform. So it is a mathematical transformation that converts a discrete time signal, which is a sequence of real and complex numbers, into a complex frequency domain representation. So it is analogous to the Laplace transform for continuous time signals. So mathematically, is a transform of a discrete time signal x of n is defined as capital X of z as shown in the equation, which is given by summation of n is equal to minus infinity to infinity x of n z power minus n, where x of z is the z transform of a signal x of n. X of n is the discrete time signal. Z is a complex variable. So the Z transform essentially decomposes the discrete time signal into a sum of complex exponentials, each with a different frequency and amplitude. So the complex variable is represented by Z is equal to R e power j omega, where R is the magnitude of Z, W is the angle of frequency of Z. So next we will see about the types of is a transform. So there are two types, which is unilateral or one-sided is a transform, where your summation will come only on the positive side, that is the right hand side of the Z plane, which is n is equal to 0 to infinity as shown in the equation. Next one is bilateral or two-sided is a transform, where on both the sides we will be calculating, which shown in the expression n is equal to minus infinity to infinity. So next we will see what is region of convergence. So it is a crucial aspect of the Z transform. So it is the set of values of Z for which the Z transform converges. That is, the summation in the definition converges to a finite value. So ROC is typically a ring or disk in the complex Z plane, which is centered at the origin. So some important thing in the ROC is its uniqueness. So the Z transform along with its ROC uniquely defines the discrete time signal x of n. Different signals can have the same algebraic expression for their Z transform but different ROCs. The ROC can be used to determine the stability of a discrete time system. So if ROC includes the unit circle modulus of Z is equal to 1, then the system is stable. Causality also comes here, where the ROC can also indicate whether a system is a causal or an anti-causal system. So next we'll see about the properties of ROC. So ROC is a ring or disk in the Z plane centered at the origin, and it is given by the shape of the ROC. So the ROC does not contain any poles. So for a right-sided sequence, the ROC will be outside a circle, and for a left-sided sequence, the ROC is inside a circle. For two-sided sequence, ROC will be a ring. So if the Z transform converges from modulus of Z is equal to 1, then the discrete time Fourier transform will exist. Next, we will see applications of Z transform. So the Z transform has numerous applications in various fields, including digital signal processing, control systems, communications, image processing, and time series analysis. In digital signal processing, it is used for designing digital filters with specific frequency responses and analyzing the stability and performance of a discrete time systems, performing convolution operations efficiently in the Z domain. In control systems, it is used for representing the discrete time control systems using transfer functions and determining the stability of the closed loop control systems and designing digital controllers to meet performance specifications. In communication field, it is used for analyzing and designing a digital modulation and demodulation schemes, compensating for channel distortions in the digital communication systems by channel equalization. In image processing, it is used as image filtering by applying the filters to images for noise reduction, edge detection, and other image enhancement tasks. And next one is time series analysis. In that, it is used for analyzing and forecasting the time series data using auto-regressive or moving average and auto-regressive moving average models. So let's sum up what we have seen here. So we have seen about the definition of Z transform, its types, what is region of convergence, then applications of Z transform in DSP, and what are stability and uniqueness of Z transform. So hope you understood Z transform clearly. Let us take up some assessment questions. What is the set of all values of Z for which x of Z attain a final value? Yes, the answer is region of convergence. It is the definition of region of convergence. So next one is, what is ROC of the signal x of n is equal to del of n minus k for k greater than 0? So as answer is entire Z plane except at Z is equal to 0. So these are the references you can refer for the introduction to Z transform and its types. Thank you for watching this video.